we're going to get the Rover working now. So time for a bit of coding, a bit of Python. We're going to make sure that battery is just plugged out, okay? Because actually sometimes that half turns on the Pi and it gets confused. And yeah, just make sure the batteries are out before you plug in the Pi. Right, we're going to follow those control wires once you plug in a Pi. And we're going to put them into GPIO 17 and the ground beside it. And on the right hand side for the right wheel, we're going to go for GPIO 23. And that's going to be for the right wheel. Okay. So you can put in the batteries now. Just to say what's going on here, if I set pin 23 on one side of the wheel to 5 volts high and the other side to ground, current flows. If it's the same voltage, 0, 0 or 5, 5 on either side, no current flows. So you want a voltage difference there. So this is all the code you need to get GPIOs working on the Raspberry Pi, turning stuff on and off. What makes this actually a little bit easier to remember is that it follows a pattern. It's uppercase GPIO, lowercase number, uppercase GPIO, and then uppercase setting, high, low, or whatever. So let's look for that pattern in the code again. Starts off with a capital GPIO, lowercase, number, uppercase GPIO, and then a setting in uppercase. Starts off with a capital GPIO, lowercase, number, uppercase GPIO, and then a setting in uppercase. So let's get started. Just as a reminder, you can type ls to find your previous code if you've made any. It's probably in the root folder there. We're going to make a new file using nano. So nano, it's like a notepad, and a file name, let's just call it newcody.py. So we're going to start off by just importing time, and that allows us to use like sleep brackets 1 to pause for a second if you want to. Now we're going to import now the GPIO stuff. So we type import or pi dot GPIO in caps. They love putting GPIO in caps as, guess what? GPIO in caps. Yeah. So that allows us to use GPIO in this Python program. Now I'm going to set up GPIO.setMode. I'm going to set the mode to BCM, and that basically, there's two different labeling systems for your pin. There's board and BCM. We are going to use BCM. So check it out. GPIO, lowercase, uppercase, uppercase. There you go. There's a pattern again. GPIO.BCM. I'm going to type GPIO, caps, lowercase, setup, brackets. I'm going to use pin 23, comma, space, watch out for the space, GPIO dot out for output. And this, sets a pin 23 for an output. Sometimes I don't know if the motors aren't working or my program's not working. So I'm going to put a print statement here to say that, this will always print if the program runs. So I know if the motors is the problem, it's always good to put a print statement there. Now, GPIO.output 23 GPIO.I, as in on. I'm turning on that motor. Turning on pin 23, setting it to 5 volts. Let's turn it off again. So GPIO.output, or open brackets, 23, comma, space, GPIO.low for 0 volts off. That should return it off. Really, actually, I should put labels on these things. This program won't really work though, because it'll just turn the motor on for a microsecond and then off again. So I really need to put a delay in here. So I'm going to put sleep, wait a second, leave it on there for a second, then turn it off after 1 second. And last but not least, I've got to put in a little bit of code at the end, just in case when my program is finished, my motors stay on. Because I don't want to exit my program and my motor's still spinning and then it's just a bit mad. So we type GPIO.cleanup bracket bracket, and that actually will shut down all GPIOs. It's kind of like the cleanup. Well, it is. It even has the word cleanup in it. So easy to remember. So that's my program all ready to go. I'm going to hit Control and O to save this. It's kind of weird. It's not Control S actually. It's Control and O and Nano. Nano is an ancient program from the time of the dinosaurs where they press Control O to save. I don't know what even O stands for. That's crazy. But anyway, it's Control O to save. Go figure. Then you know, type in a new name if you want or not. Hit accept, bash, return, find exit. It's X, Control X, which is normally cut, but hey, ancient programs. I guess X kind of makes sense for an exit. Exit, yeah, cool. So I'm going to do that now. I'm going to hit Control O to save it. I hit return, yeah, and hit Control X to exit the program. Deadly, that's it. So there's my program there. What was it, new Cody or something like that? Yeah, .py or Python. Grand, so I'm going to go sudo python, name the file to run that file. So sudo python new cody.py, and let's see how many errors there are. Yeah, I know where that is. That's a classic. I think I even talked about, maybe I talked myself into this error. It's OR_PY right at the start. When you import OR_PY GPIO, it's capital OR, capital P, and small I, which is really weird and annoying. Like, why not all caps or all lowercase? The first two, OR_PY, are uppercase, and the little baby I. There you go. I added all caps. Okay, it's fixed now. So I've gone Control O, Control X, save, exit. Let's run it again. And yeah, deadly. I hear motors going, so class. So that's the code to get the left motor going. If I put the left motor wires into pin 23 and ground. But let's say I want to make the right wheels move. If I want to like turn left or right, I need really both wheels to go forward. So, you know, it's pretty simple. You just get the left wheel and you just copy it and you just change it to, let's say I plug the right wheels into pin 17. Look at that, 17. And now 17 will go as well as 23 there. Oh, one important thing. Don't forget I have to set up 17 as well. The setup. Right, so setting up those two, moving 17 on, pause off, turning 23 on, pause off. So this could be my left wheels and this could be my right wheels. And if I turn on two of them together and go forward, if I turn on just one of them, I'll probably turn some direction. So that should be everything now you need to move a rover around. You should be able to write a program that can navigate a rover around an obstacle and come back. That is the challenge.